All right, Eric, we are so sorry that you're not here. What you're going to need to do this lesson at home is a graphing calculator, some graph paper. You can pull up the ebook if you want, but you don't really need to. So I had planned, and we'll see how far we get because Eric, obviously you're not here. I had planned to do 423 and 424 today. We might only do 23, but we're skipping 22. So like for purposes of your homework, make a mental note, like we're skipping 22 because 22's just all about selecting which trig function of sine versus cosine versus tangent, which I think you guys got down pat pretty well with just SOHCAHTOA, right? If we're talking about opposite and hypotenuse, we're going to default to sine, adjacent hypotenuse cosine, and opposite adjacent is going to be tangent, right? So now we're going to the inverse trigonometry of where we're trying to find out an unknown angle based off pieces that we have. So Mr. Gow needs to build a wheelchair access ramp to the school's auditorium. The ramp must rise a total of 3 feet to get from the ground to the entrance of the building. And in order to follow code, this is like legit ADA type stuff. And it might even be less than that now, because we'll look at what a 4.76 degree angle looks like. But let's calculate, does he have enough distance to be within code, or would he need a longer distance? So I want you guys, the planning department says the ramp should be 25 feet away. Like starts at 25 feet away. Needs to have a rise of 3 feet, and to be by code, it cannot exceed, so it could be equal to, right? Cannot exceed. Go ahead and try that out. See what you think we would do. I don't want to move everything down in a way. Now we'll do this. Yeah. I do. All right, I'll make sure it comes back to me because it doesn't say my name, but it does say 603. So thank you. So we know that this has to be 3 feet. Now, what else are you plugging in? Are you using the 25 or the 4 point whatever? Yeah, because the 25 is like what we have to work with. And then we can calculate what this comes out to be. Now, what is our placeholder when we're talking about angle measures? You guys remember what we call that symbol? Theta, right? That's the Greek letter theta. Looks like an Easter egg, right? There's a little oval squiggly through the middle. Literally, that's theta. So when we are looking at this angle and comparing to here and here, what trig function are we going to use? Tangent. So we set up tangent of theta equals 3 over 25. Now we could go reference our little table that we have and say, well, which angle is close to whatever 3/25ths, what, 12? It's like 12 over 100, right? Or how do we get theta by itself? Since tangent is a function, how do we undo any function? It's inverse. So the inverse of tangent on your calculator is just the second, so hit the second button, and then hit tangent, and you're going to get tangent to the -1, which is the calculator's way of showing that is the inverse of tangent, because we use that notation. Now make sure that you are on degrees, otherwise you're going to get an answer spit out in pi form because it's going to be radians. So if I do inverse tangent of 3 over 25, ooh, what's that tell us? It's out of code, right? Because this is too high of an angle, right? So what I need you guys to figure out then is, okay, forget about the limitations that we have. If we must be within code, And maybe this means we're going to have the ramp have like a turn, right? Like some kind of like, if I don't have the linear space, I might have to turn at some point. Figure out how long this would need to be, because we're going to say, okay, strike that. We can't make it 25, but we must make this 4.76 or less. So why don't we just go ahead and say like 4.75, I guess, since we said cannot exceed. But so I'm going to erase this because we don't know that now. We can say 4.75 degrees. So then, are we still using tangent? Yeah, because we're still talking about opposite and adjacent, right? Now, what's like the quick, I don't remember with like cross multiplication strategies. Yeah, you can just switch them, right? So remember that if we want to write out this work, you can multiply and then divide and justify why this is allowed. But we can really just do 3 divided by tangent of 4.75. 36 point what? 1. So if we had 37 feet, like we'd be fine. Or we might have to so if it's coming this way, we might have to turn and like go another way to be able to have the run that we need. Right? If you've ever like been to a building where their ramp does any sort of like weird, that's why. Right? If you ever looked at something, you're like, I wonder why that got designed like that. There's some code that is going to require it has to meet certain whatever. So anytime you wonder why is that the way it is because of, I don't necessarily want to say like silly rules or laws, but like for that, definitely not silly, right? It's trying to make sure that a disabled person can get into a building. Now there are other codes or whatever that is like, you must have an electrical outlet every so many feet, or like that are sometimes annoying. And I'm only saying that because my friend who is an architect like has talked about this stuff, and he's like, oh yeah, you got to get it to code. So here, if I ask you to find angle A, what trig function are you going to think about using? Cosine, because we'd be talking about adjacent and hypotenuse. If I ask you to find angle B, what would you think about using? So we didn't change the numbers that we have. And if I know B, I could find A. If I know A, I could find B. So essentially we could use either sine or cosine kind of interchangeably. Right? Like, we got to double check how we set up our work. But so solve this somehow. Either solve for A using cosine and then figure out what B is, or solve for B using sine and then figure out what A is. Right? So go ahead. This is just a nice example of like, well, sine and cosine work kind of together because it depends on which angle we're referencing. Daresh, what'd you get for angle A?
21.04.
Meaning, Dionysus, your angle B should be, because those angles must be. Yeah, sometimes we got to pull that word back, like from deep back there, right? Complementary, right? Add up to 90. All right, let's do another, because I think we'll probably be able to get to some more problems. Try these. I bet you barely even need like a minute. Especially because I think both of you already were like, oh, well, yeah. I saw the looks on your faces. 424 is more fun. So as soon as I know that we're like comfortable with this, we'll just go do some applications. Uh-oh. Now in A, it looks like the hypotenuse is double that leg. And for theta, we got, because A is what kind of triangle? Yeah, my mom used to say that about me, but now I'm starting to question what it meant. No, A is a special right triangle because it's a 30, 60, 90. Remember, one of those relationships that we saw is when the hypotenuse is double the short leg. So then what would the long leg be here? Because if theta is 60, that means the long leg, do you remember what we said?
12 divided by pi over 3, or 12 times pi over 3?
How could we figure that out real quick? If we don't remember the rules, how can we figure it out real quick?
Just put,
Pythagorean, right?
oh, yeah.
Well, I mean, or we could use trig, I guess, now that we have an angle measure, but never use something you just found if you can use all things that were given to you. So real quick, what's 24 squared minus 12 squared and the square root of that? Try that real quick.
Because you said something about the special thing. So
Oh, I know.
we'll do something like
You don't have to have this stuff memorized yet, but by the time you need to have it memorized, or like we start actually technically learning it, I want you to already be comfortable with it. (24 squared minus 12 squared).
20.78.
Yeah, and then the square root of that. So 20.78. How does that compare to 12?
Well, I was thinking
Do you remember what it is?
3.
Radical, is it 3?
Yeah. It is.
You can remember the radical 3 because 30, 60, 90 are all multiples of 3. Right? So 30, 60, 90 either uses the one is double the other or radical 3. Right? So radical 3 is that middle length leg. Our short leg is our reference point that we keep working from, and our hypotenuse is always double. All right, and
Was I saying pi over 3?
I don't. Is pi over 3 equal to radical 3? I think you said something over. You said like a rational number.
Oh, I don't know. Okay.
And B, Eric, what'd you get for B? I just wanted to make him like, wait, what? Call on him through the. He's not gonna watch the video probably, but either way, what would B be? 45. We know that just by inspection because it's isosceles. And C, 8.35. Yep. All right, sweet. We're going to skip over the, hey, Peter made a mistake question because we don't really need to do that, and I would rather get to some application. So assuming that we get through this, which we will because we have like 25 minutes left, I'll probably just have you do 24, or sorry, like 4.2.4 for homework. I don't think there's anything in 3 that I need you to do. Yeah, they're not bad problems, but I don't think we like need to do any of those. I think the 424 practice is more important. So, all right, let's read this first situation here. All right, so go ahead and read this, decide what you think is important, and if you want, start drawing a diagram. I just noticed how angry this makes me. That they just called a carabiner a rope pulley. Carabiner's just a clip. Interesting. There's a part of this that makes it feel like it's different than what we've done before. So it's not, the 48 isn't just the hypotenuse. The 48, absolutely, except those are, oh, you need empties.
Oh, I need empty.
Sure, yeah, I was about to say, those are full and
No,
new,
no,
but
I need
those,
empty.
I haven't even drank out of those, I just dump them into my water bottle, so they should be clean.
Thank you.
You're welcome. Huh. Alright. So 55-degree angle with the ground. So I guess that means that.
And he's 3 feet off the
Yeah, we should probably think about that at some point, but we might be able to wait till like the end to apply that 3 feet, but like don't forget about it. Ooh, there's one more piece of info.
ground. Would the blue line be the 20 feet?
Yeah, I guess I probably shouldn't have. I did that as the ground since they said angle with the ground. But yeah, I mean, I guess really like 20 feet away. So this would be 20. Ooh, did not mean for it to be that big. So if we draw the line down here, right? I mean, go ahead. I think we have everything we need. Eric, you should race us. Since you're doing this at home and you can do it in real time. Now don't pause the video, Eric. You should race and see if you can do it faster.
I got 20. And then 31.56.
You got what now?
Including the, like, we're adding the 3 feet.
So which are you giving me for how high up she is? So wait, how high up are you saying she is?
28.56.
No.
So if you add 3 more feet to it, it would be 31.
Nah, you're too high. What? No, wait. Her harness is... Oh, I see what mistake you guys are making. Again, is that how high she is? Sorry, sometimes I get goofy with my answer key because I haven't taught this lesson in a year. You're 28 point whatever you got. Sorry, I ripped this and I need to fix it. What is your 28? The
Right.
triangle,
How high she is from the ground.
well, that's not true. Your 28 is what now?
How high the rope is?
How high up that carabiner is. Have you guys figured out the math of the rope? Of how much rope is between, like, how much rope is the hypotenuse and how much rope goes down to her? Because to figure out how high she is, we can't just figure out how high the carabiner is, because she's not there yet. So you're right, 28.56, but that is the entire height from carabiner all the way down to the ground.
Oh, she's not that high.
She's not that high. We need to subtract this portion. To be able to subtract that portion, what do we actually need to find? The hypotenuse amount of rope. So we need to find the hypotenuse if we haven't found it yet. Have you found the hypotenuse?
Isn't it 48?
48 feet of rope, which goes up to the carabiner, and then back down. So 48 is from here to here.
Wait, oh.
Can you solve for the hypotenuse right now?
Yeah.
Yes. Do that.
Is it 34.87?
Yes. So how much rope does that leave from the carabiner down to Emily?
13.
Yeah, so then take that away from the other value that you just got. So you had 28.56. Take away the 13.13.
It's 15.43.
Yeah, 15.43. All right. Questions on that, or did we just not think deep enough at first?
And
Yeah, I think we just didn't think deep enough. All right. Let's try another. The Bungling Brothers, different situation. Burgle Brothers is a board game company. My bad. By the way, we're starting a tabletop gaming club on Wednesdays and Thursdays. 7th graders Eli, Bryson, and Grace are in charge of it. If you guys want to spread word to 8th grade, we should probably come put some posters up over where 8th grade can see it. Lunch and extensions. Any tabletop games. No digital, like no video games, just tabletop games. So
ping pong.
no, like board games, card games, like whatever. All right, so the Bungling Brothers Circus is in town, and you are part of the crew that is setting up the enormous tent. The center pole that holds up the tent is 70 feet tall. To keep it upright, support cables, normally called guy wires, I don't know why we call them guy wires, need to be attached to the top of the pole so that the cable forms a 60-degree angle to the ground. Now, you might be in your brain remembering one of those things that we know about 60-degree angle triangles. When we go to draw this, we want to make sure that we really think critically. So 70 feet is our pole. And 60 degrees is at the base, right? Which I can barely fit my degree symbol. Pretty steep, actually. Yeah, 60-degree angle with the ground. By the way, we call this an angle of elevation when it's against the ground, as opposed to against the vertical. So, we got two different questions to answer here, right? How long does this cable need to be, and how far from the ground does it need to be? And I think I remember that one of these should be half, Or like there's a times 2 relationship. Which of these should be the half of 70? The what? Why? What is this angle? Making this side our what? Our short side, right? Our short leg. Because hinge theorem, that we've talked about a tiny bit and we will keep talking about more, says the side across from the smaller angle is gonna be the smaller side. And the short leg, is half of, crap, it's half of the what? Half of the hypotenuse. Crap, we can't just make that 35. There is a 1/2 relationship here, but we gotta find the hypotenuse first. How do we find the hypotenuse related to the long leg?
Multiply by 2.
So the hypotenuse is double the long leg? Crap. This gets into like, we haven't practiced these 30, 60, 90 rules. Maybe we should just use trig. Like, and guys, everything I'm doing is on purpose. There are rules that we could use, but if we haven't practiced them, trig is the safer way to go. I know the 30, 60, 90 rules, but that doesn't matter. Right? If you're not comfortable with them yet, let's just do trig. So if we just do trig, and we want to solve, I don't know, the cable away from the ground, that's the adjacent. We have, really we could work either direction. We could use the 30 or the 60. But if I do, I don't know, my 60 degrees, let's just use tangent then, right? So tangent of 60 equals, wait a second, opposite over adjacent. So that's going to be, I'm going to call it like G for distance to ground, or like ground distance. And then we're going to swap those, right? So what is 70 divided by tangent of 60?
40.01.
So then hypothetically, we think the hypotenuse is double that. But double check the trig. Let's instead of, so sorry, you said this is for what? 40.4. Let's check the trig and say, okay, from 60, even though we could use the 30, let's use opposite hypotenuse, so sine, right, of 60, opposite over hypotenuse, swap them again. If what we said is true, then this should be about 80. Yeah? So what that means here is the relationship that you guys don't know yet is this, is times radical 3.
Okay, I just wrote down.
And it really only comes with practice, right? And at this point, we aren't supposed to have told this to you yet. We're supposed to be hoping that at some point you'll be like, wait a minute, does that always happen? But I'd rather just tell you guys to be like, hey, because this is half of an equilateral triangle, it makes sense. And actually, we can get really crazy and say that if you put 2 equilateral triangles together, you get another geometric shape that has other geometric proofs and things that have to hold true, and but we'll get to that. All right, so another different question now. Try this one. I don't think I need to really guide you at all. So instead, I'm going to find a little bit of a clip talking about LCAP. Hey, Eric, I don't know if my recording is going to keep working, and or we may not even finish this problem today. We might just wait till Wednesday to finish this stuff out. But I'm going to pause my recording because I'm going to show a trailer about LCAP.